Hi everyone, thanks for watching my YouTube contents. I'm Sang Kim. In this video, I would like to help you understand how to calculate Martingale and Deviance residuals in Excel and R. There are a couple of websites I have used for this video, and there are three types of diagnostics for the Cox model. The first one is testing the proportional hazard assumption. Second one is examining inflation observations or outliers. The third one is detecting non-linearity in relationship between the log hazard and the coverage. So Schoenfeld residuals, Martingale residuals, Deviance residuals are popular to analyze residuals. So in this video, I would like to focus on Martingale residual and Deviance residual. Martingale residual is to assess non-linearity, and Deviance residual is to examine inflation observations. According to Hosmer, Lemeshow, and Maybook, Cox-Snell residuals can be calculated by using this formula. The first part is, as you can see, it is baseline cumulative hazard. And the second part is covariate part. So these are called Cox-Snell residuals. Actually, Martingale residuals is event minus Cox-Snell residuals. So the meaning of this Martingale residual is the discrepancy between the observed value of subject failure indicator and its expected value. Martingale residuals are very useful to identify outliers and choose a functional form for the covariate. However, it has a drawback. But the sum of squares of Martingale residuals cannot be used as a good measure of goodness of fit. The Deviance residual is an alternative that does have this property. Measure of goodness of fit. This is a Deviance formula, and these residuals are symmetrically distributed with expected value 0. In our program, once you have Cox proportional hazard model, then you can use residual functions and specify type as Martingale or Deviance. Then you can get these Martingale or Deviance residuals. Right, let me show you how to get these Cox-Snell, Martingale, Deviance residuals in Excel. Let's say initial value. Let's set initial value for Rx and age as 0. Then you can calculate x vita. X vita can be calculated by Rx times Rx coefficient plus age times age coefficient. And exponential of x vita can be calculated by using exp function. And partial log likelihood can be calculated by if you stat equals 1, then x vita minus log of sum of x vita as a counting process. If not, let's set value as 0. We want to maximize this partial log likelihood. Right, then go to data tab and click server. So we want to maximize this cell by changing coefficient values here. Then click serve. Right, these are estimated coefficients for Rx and age. So baseline hazard, if we use that, equals 1, then 1 over sum of x vita. If not, let's give a value as 0. Right. Then cumulative baseline hazard for first row is same, and the second row for cumulative baseline hazard can be calculated by this plus this one, previous one. Right. So Cox-Snell again. this one. Cumulative baseline hazards times exponential of x beta, this one. Then Martingale residuals is actually events. If you use that, means minus Cox Snell. These are same as our output. Right. Then deviance can be calculated by using this formula. So if sine of Martingale residual, Martingale residual is greater than 0, then let's give a value square root of minus 2 times Martingale residual plus delta I is FU stat times 3 log of FU stat minus Martingale right. And if Martingale residual is less than 0, and minus same formula. Okay, this is same as our output, right? So I showed you how to get Martingale residual and Deviance residual in Excel. So in summary, Martingale residual is the observed value of subject failure indicator and its expected value. So Martingale residuals is 1 minus Cox Snell, and Deviance residual is to actually make Martingale residual as symmetric to have symmetric distribution, right? I hope it was useful to understand how to calculate Martingale residuals and Deviance residuals in Excel and R. Please click like and subscribe if it was useful for you. Thank you.